Hello everyone, we are Group 5 and our group is going to be presenting Human Performance Using an Exoskeleton by me, Ana Hernandez, Emily Garcia, Saul, and Rene Saldana. So first things first, what is an exoskeleton? An exoskeleton is a wearable robotic device that is designed to enhance the physical capabilities of the wearer. It typically consists of rigid or flexible structures, power joints, sensors, and actuators. Exoskeletons can assist with various movements such as walking, lifting, and carrying heavy loads, and by augmenting the user's strength.
Types of exoskeletons: rehabilitation. Robotic rehabilitation provides repetitive, flexible, and customizable exercises that complement physiotherapist work aimed at the functional recovery of patients who report impairments or disorders deriving from stroke, brain or spinal cord injuries, amyotrophic lateral sclerosis, orthopedic surgery, or cerebral palsy. Assistive robotic exoskeletons can be effectively used to help the elderly or permanently injured in carrying out the most important activities of daily living with more independence, attempting to compensate for disabilities or partial function loss. Walking, grasping, and handling objects and eating are some of these core activities. Haptic interaction. Haptic exoskeletons interact with the user through the sense of touch, and their main function is not to cause or resist movement, but rather to provide the user with tactile sensation. Coaching devices are non-actuated devices that do not generate any forces but provide different feedback. They can serve as an input interface for interaction with games in virtual reality, such as systems using video-based motion recognition. Performance augmentation. Similarly, different technologies are used for sensing purposes in exoskeletons, such as measures relating to the movement of specific limbs, forces or torques exchanged between device and user. Biosignals such as electromyography signals, electroencephalography signals, and mechanomyography signals.
So there are benefits to using the exoskeleton. Some of the benefits that I found throughout my research were injury prevention, enhanced performance, and load management. For injury prevention, the exoskeleton provides additional support to vulnerable areas that are not as strong as other areas in the body, such as the knees, the ankles, and our spinal cord, or our spine, reducing the strain on joints during high-impact movements like tackling and jumping, and it minimizes the risk of ligament tears and or sprains. So using the exoskeleton also enhances the performance, so augment players' physical capabilities such as strength, speed, and endurance. It provides assistance during training and or conditioning exercises, and the exoskeletons may help athletes push to their limits and improve overall performance in training or on the field. And then, of course, we have the load management. The exoskeletons are equipped with sensors and feedback mechanisms that can help coaches and trainers monitor the players' exertion levels and manage workload more effectively. And it also tracks your momentum and impulse, and it can assist in optimizing the training programs. So how we plan to use the exoskeleton. So it's by using sensors and actuation. When looking at force sensing equipment, wearable sensors, and force plates, it can be integrated into training apparel or equipment used during practice sessions to prevent injuries from occurring. These sensors can provide real-time feedback on the forces exerted during movements such as sprinting, jumping, or tackling. Analyzing this data helps athletes understand their momentum and impulse characteristics and optimize their technique accordingly. Our approach is to design new sensors to measure human kinematics and suit human interaction forces that are robust, compliant, and effective, and offer easy integration into wearable garments.
Research on
Hello, my name is Emily Garcia, and today I will be presenting the statistics on exoskeleton. This is very important to know because when building a exoskeleton, you gotta be prepared for the obstacles you may go through. And one of the obstacles that you are going to go through is the statistics and how much it costs and what you will need to build an exoskeleton yourself. From my research on what the exoskeleton is and how much it costs, it ranges from thousands to $10,000s to build one. And many factors go into play when you're talking about how much this costs, such as the supplies that are used, the complexity of the design, and the volume of the production. One example that I found was about the Phoenix exoskeleton, which weighs approximately 27 pounds and is estimated to go at a speed of 1.1 miles per hour. Just this alone is estimated to be around $40,000 to build and to have or to buy.
So, what does momentum and impulse mean in sports? More specifically, in biomechanics, momentum and impulse are both important concepts that relate to the analysis of sports movements and athletic performance. Momentum refers to the quantity of motion that an object possesses. It's the product of an object's mass and its velocity. In sports biomechanics, momentum helps in understanding how much force is needed to accelerate or decelerate an athlete or an object during various movements. Impulse is the change in momentum experienced by an object when a force is applied to it over a certain period of time. Impulse can be calculated as the integral of force concerning time.
Exoskeleton in sports. When looking at force sensing equipment, wearable sensors and force plates can be integrated into training apparel or equipment used during practice sessions. These sensors can provide real-time feedback on the forces exerted during movements such as sprinting, jumping, or tackling. Analyzing this data helps athletes understand their momentum and impulse characteristics and could help optimize their technique accordingly. How momentum and impulse are used in football. Let's start with the basics. Tackling. The effectiveness of a tackle often depends on the collision between the tackler and the ball carrier. Players are taught to keep a low center of gravity and drive through the opponent's core. This technique maximizes the impulse applied to the ball carrier, reducing their momentum and bringing them down effectively. We got blocking. Offensive linemen aim to engage with defensive players to disrupt their momentum and control the line of scrimmage. Both offensive and defensive linemen engage in a physical battle at the line of scrimmage. By generating a larger impulse, blockers can overcome the defender's momentum and dictate the direction of the play. Running and passing. Running backs use techniques like stiff arms, spin moves, and jukes to maintain their forward momentum. Quarterbacks can maximize the momentum behind the passes by rotating their hips and transferring their weights or using better footwork. Receivers use quick cuts, changes in directions, and acceleration to exploit momentum and gain an advantage over defenders in coverage.
So, pressure sensors in football equipment. In another PubMed research article, it presents a novel method using TechScan sensors for measuring in vivo compact intensities during a front-on tackle to assess the effectiveness of rugby shoulder padding in reducing peak force during impact, which also means preventing injuries. Reinventing this technology, we can calculate the amount of force being generated and how much power the athlete can handle, withstand, and distribute throughout their body. Implementing this into football equipment and using it during practice and games can give us an insight on how momentum and impulse really play a part of the sport.
To know about when talking about the exoskeleton regarding sports is what types of injuries you should expect in that certain sport, and how you can implement the exoskeleton in that sport. One of the sports that we chose to talk about in our project is football. There are many types of injuries you can expect with football because football is a very rigorous sport. 3 of the most common injuries, according to my research in football, were an MCL sprain, a meniscus tear, and an ACL tear, which are all in the knee and happen because of the quick change in direction and the quick stops, rigorous movement that you do. And these are all lower extremity injuries, so this is a very good candidate for an exoskeleton that is below the waist. Something else that you can expect, or more injuries that you can expect in football, are ankle sprains, muscle sprains, and knee injuries, overuse injuries, things like that, because of how much you're playing and practicing the sport. And also, like I said at the beginning, football is a very rigorous and hard sport that has to do with a lot of contact and non-contact things, and sometimes the pads in football aren't always the best or aren't always the safest, so things like this can also be very good candidates of exoskeleton, because exoskeleton will help you regain muscle and basically help you relearn how to use your muscles and bones in your body. Some of the more severe, those were some of the less severe injuries. Some of the more severe injuries are things such as concussions and severe neck and spinal injuries, which all have been to be, and most times, career-ending, or can cause you to be paralyzed. So exoskeleton is a very good thing to use post-traumatic injury. That way, you can just do simple things, because even though you might not be able to play football again after you get paralyzed, it's still good to have something to help you move around at home and do simple little things such as go to the restroom. Most of them have comments. With every invention, there is some pros and cons that can come about when creating something, when testing something out. Exoskeleton is still pretty new to the world, and there is a lot of different prototypes and things like that people are coming up with. And as people are using it and people are practicing using it, there have been some pros and cons that have come about, and most of them have something in common. Some pros that I read about the exoskeleton were that it increases muscular health, increases personal mobility post-traumatic injury, such as spinal cord injury, because spinal cords are very sensitive and it's very hard to move around when you have a spinal cord injury. So using something as support, such as an exoskeleton, will help you reduce injury and help you regain mobility at the same time. This also helps aid mental health, because not being able to move as much and being limited or needing help from people is always something that lowers your self-esteem, causes mental health problems such as depression, anxiety. So having something that helps you move around and helps you see progress in how your body is healing is something that's very beneficial for mental health. Some cons about the exoskeleton are it's very hard to get medical clearance for it, just because of insurance purposes and certain injuries that don't meet standards or requirements, qualifications for you to get the exoskeleton, just because it is pretty new. So getting cleared for something like this is very difficult. Like I said earlier, a patient needs to meet certain medical standards and qualifications. So meeting those, depending on what type of prototype or what type of exoskeleton, is pretty hard. And also something very simple like limitations and safety measures, just because we don't know much about the exoskeleton and everything is still in trial. So we don't know how far the exoskeleton can go in helping somebody out. So just safety measures and limitations are very big on why not a lot of people can try out the exoskeleton. Something else I didn't add on here is that it is also very expensive, and not a lot of people can afford it, especially with paying medical bills and things like that. So paying $40,000 or something like that for an exoskeleton on top of all your medical bills is going to be very hard for somebody to just easily afford.
And then, of course, this was all of the resources that we used to complete our presentation. Thank you.